And what I'd like to do is dive a little bit deeper and make the link also to some of the things, obviously, that we're doing at Assaia in winter operations. But before that, I had sort of double feelings talking about winter operations, because on one side, I know there's many aviation professionals that are almost full-time engaged in winter operations, and they're probably much more, they're definitely much more knowledgeable about this topic than I am. On the other side, in my 8 years at Schiphol, I probably 5 years or so was part of the winter ops team. So I was actually driving these kind of trucks, clearing runways and such. So I think I kind of went back in my own winter ops archive to find some examples. And I think if there's two things that I think I wanted to share solutions on is basically inexperience. Like what we already heard is like this only happens a few times a year for many airports. And the people involved are usually not people doing this every day. And the other thing is the unpredictability. And it has mainly has to do with capacity. And I think it's important to notice that the capacity is a chain. And whatever factor has the lowest capacity is what determines the actual airport capacity. And therefore, the synchronization between all these capacities is extremely important. And Peter, if you can move to the next slide, please. I think in order to be able to synchronize capacities, you need information, both real-time and predictive information, because you want full visibility, even in low visibility conditions. And as many of you know, what we do at Assaia is that we take data from video cameras and use that to generate structured data. So when do events start? When do events end? And then also use that data again to predict when will an event typically end. And this is a picture of our system in operations in a sunny day. But it's good to know that the system works actually as reliable in days with snow. We've done projects in Finland, in Canada, where we have seen lots of snow. And we also have experience in detecting the start and ending of de-icing operations or anti-icing operations. So that's something that we have experience with and something that we actually know works very well. So let us see in the next few slides how we can take that technology and make use of that in the challenges that we've seen. So first of all, if you have the airport and if it has been snowing, or even worse, if it is still snowing, the gate planner at the airport needs to know, what's my gate capacity? How many inbound flights can I even accommodate based on stand availability, and which stands are only available for parking because they're fully covered in snow, or which ones are actually able to service aircraft and even have passengers on and off boarding. So typically, what will be the case is there's actually people driving around reporting back to the tower, back to the gate planner, what's the condition of certain stands. And either there will be a system or even a spreadsheet, keeping track of, what's the color coding. Is it green? Is it yellow? Is it orange? Is it red? What's the position of each stand to be used as an input for stand planning purposes? So the way how we see that, that's labor intensive, therefore cost inefficient, potentially prone to human error. And on top of that, you don't have someone at each stand all the time. So you don't have real-time information. So you're always sort of chasing reality and chasing the actual situation, especially if it's still snowing, because then the condition can actually change on a minute per minute basis. So why not, use cameras that you often already have overlooking the apron to see actually what's the snow condition at the stand in order to be able to manage your stand planning in real time based on the real time situation that you have there. Then if you move to the next slide and we look to on-stand de-icing, and especially in relation to departure management, it's interesting to realize de-icing can obviously only start if all the other operations in a turnaround have ended. So first of all, the start of the de-icing on stand depends on all of that. So it's important to know when that will be, not as accurate as possible, obviously. But then, of course, you only want to start de-icing once you know that after you finish de-icing, the aircraft will have a smooth flow over the taxiways to the runway and can directly take off. Because if you take the act of de-icing the aircraft and you spend the de-icing fluid, you spend the resources, you spend the time of the truck and the staff on de-icing the aircraft the aircraft will be sent off blocks and is then standing in a queue and potentially even over extends its time frame and needs to be de-iced or anti-iced again, that's obviously highly inefficient. So there's one thing where we think, if we can actually see the progress of de-icing, if we can have the system observe, how that's progressing for each departing aircraft, for each on-stand de-icing operation, we can actually predict when is it expected to be ready, so that we actually know per time frame into the future. So let's say in the next 15 to 20 to 30 minutes, which aircraft will be ready for departure, then model these aircraft's path towards the runway. Also, again, preferably based on real-time traffic data, predict the taxi time, know when they are at the runway, so we can calculate backwards when should this de-icing operation start, what's the ideal moment, so that they don't have any queuing and potentially need to be de-iced again. So the real-time information, when can de-icing start and when is it expected to be ready, is key for a smooth departure sequence. I just talked to Nita about when should de-icing start, and the interesting part is if you look at a medium to large sized airport, they'll have dozens, if not hundreds, of vehicles specifically for winter operations that are only used a few times a year. So it's highly inefficient in itself, but you need them. However, for the days that you need them, you basically want to make use of them as efficient as possible, so you need as little as possible. Because it's not just buying and owning the equipment, you also have to maintain it, do checks, so that in case there is snow, they're basically ready to go. So again, if you have 50 turnarounds going on and 50 departures planned in the next 1 hour or so, what is your resource planning going to look like? When are you going to dispatch which vehicles, which de-icing vehicles to which aircraft? Again, knowing the ideal moment of when the aircraft is ready to actually start receiving de-icing because all the other ground handling activities have ended is detrimental. And knowing this information in real time and high accuracy will actually allow you to plan de-icing equipment to aircraft in a much more efficient way, and therefore actually be able to run the same operation with much less vehicles. So if we then make the switch towards, next slide, please, Peter, to remote de-icing or the use of de-icing pads, I think it's going to get even more interesting, because here we almost have the full chain of the departure, where the aircraft at some point needs to be pushed back and start taxiing to the de-icing pad, and from there actually taxi again to the runway, and all of this needs to be optimized. So first of all, we want to know what the capacity at the de-icing pad. So how many spaces, how many simultaneous de-icing operations can be done, how many of those are currently occupied, in what stage are they, how much longer are they predicted to be going on. Again, in order to calculate backwards the ideal time for any other aircraft to be given clearance to actually go to the de-icing pad. And to get this game right is actually, it's pretty hard if you don't have the information. And what you typically see is that a lot of aircrafts will be given the clearance to go off the gate and start taxiing towards the de-icing pad, which then results in a big queue at the de-icing pad before the de-icing pad. And that's all aircraft that are burning CO2, burning fuel, which is bad for the environment, which is a hot topic if we want to build back better after COVID, and which costs money because we're burning kerosene for nothing, which in terms of cost efficiency, I think is also a pretty big topic today. So to get that right, to basically give the clearances from the stand to the de-icing pad at the right moment, but also taking into account the capacity of the de-icing pad into the downward journey towards the runway, again, to make sure that the aircraft doesn't have to stand in line there and run the risk of having to be de-iced again or anti-iced again. So these are, a few of the things where we think, it makes perfect sense to use data analytics and predictions. And it's not just from cameras and aircraft stands, but also, if you want to have information about runway availability, why not use data from vehicles, from snow clearing vehicles, in order to predict how much longer the runway is actually going to be unavailable because they're still cleaning, and when is the time actually that the runway can be put in use again. if we move to the next slide, there's a few other, I think, major innovations there that I wanted to mention because I think they fit exceptionally well into the topic. One is the Snowbot, which is an innovation that has been trialed together with Finavia in Finland. And obviously it holds many advantages, A, because of safety. Again, I was one of the people that actually were operating trucks a few times per year maximum, which means I'm very definitely not optimally qualified to do that. If you have an autonomous system, the chance of human error is just much lower, which increases safety. Therefore, also faster clearing, again, lower operational cost. And another almost side effect, but to me, actually, maybe even the most important factor, that's a smart vehicle by design. So this vehicle by itself will create and generate data on where it is, what it has done, and therefore will actually feed into the entire chain of capacity balancing. And therefore is, I think, a very interesting solution, especially obviously for airports that have a lot of snow clearing going on. So the last thing that I wanted to mention to you, if we can move to the next slide, please, is a solution called SNOCOM. Because we're talking about snow clearing and collecting all this snow, but if you collect all the snow from an airport, which is polluted by all the materials that have been used to prevent the snow from staying on the airport, you will literally have a mountain of snow to take care of. And I've seen this firsthand. You will literally have several aircraft stands of snow, and stories high, and you will have truck operations for days, if not weeks, with digging machines, putting all this snow into trucks and then them driving it off to a post-processing facility. And the funny part is half of snow is actually air and the other half being water. And the SNOCOM solution, I think, is very interesting because it actually processes the snow, takes the air out, makes it much more compact, which means that you need less storage, so it will cost you less capacity. You will need less trucks driving up and down, which again has a safety advantage as well. And therefore, in all of that, it will just have a major impact on the operational costs of winter operations. So another thing that I thought worth mentioning and interesting if you think about innovation and winter operation. That's it for me. Looking forward to any questions you guys have.
All right, thanks, Chris. Very interesting. And I think, for example, one thing that I came across in the past was also that there's always, during winter operations, when there is very low visibility, there is a problem that some pilots that may not be very familiar with the airport go into the wrong direction. And then even if you have some kind of a de-icing lineup, then it gets or the lineup is destroyed basically, and detecting what kind of flight is actually in front of the stand if you have a pet de-icing is, in my opinion, also something that is helping a lot in the future, just to make sure that you are not thinking there will be a 737 coming and then you have a 777 in front of you, which requires a completely different de-icing process. But great, thanks